A little bit about me. These are my handles on Discord, on Twitter, and my LinkedIn profile. I'm doing security research for a company called Vectra AI, and we're doing threat detection in the cloud and in on-premise networks. And before that, I was a pen tester for a few years with IBM, and I did some secure software development advocacy. And before that, I spent a long time just doing software design and development. I come from a development background. I'm very interested in all things security. My love is reverse engineering. That's the area I'm interested in most. So before we continue, quick public service announcement. I'm part of the team that does Canada's cybersecurity challenge. It's a competition for university students. It starts with regional events every year. It's been running for about, more than 10 years now. We have over 40 teams across all Canada. They compete regionally. The winners go to Ottawa for the national competition. And those that win that, they are put together as Team Canada that competes internationally. They have so far been to Prague, to Athens, and Vienna. And they've been doing pretty good. Usually they're maybe in the middle of the scoreboard. And in Vienna, in event just this September, they actually took the first place among the guest teams, beating US and Israel, which is not too shabby. So the reason why I'm talking about this is that I'm actually inviting everyone to join us. You can be a sponsor or an employer. Actually, an interesting thing about regional events is that concurrently with this CTF that's running, employers get a chance to interview students. And very often it happens that by the end of the day, students get job offers. So if you're looking for really best and brightest in the field, it's a great opportunity for you to actually hire people on the spot. You can sponsor the event to just promote the next generation of cyber defenders. We also need help organizing the events. If you're good at building challenges, testing challenges, maybe helping with organization stuff, we would be happy to have you. And if you're still a student, it's a great opportunity for you to either start a team at your university or maybe join the team that you already have. So just a really great event, fun challenge. And there's a QR code for the website if you want to reach out to us. So what I will be talking about. So we'll start with an introduction to Microsoft 365. We'll talk about security expectations in the cloud because they differ from those on on-prem networks. I'll mention some recent incidents in that area, and we'll talk a lot about popular attack techniques against that environment. And then I'll talk about defender tools and defense strategies. So what is Microsoft 365? Probably a lot of you have heard of it. Actually, by a show of hands, who is using Microsoft 365 or Office 365? OK, so that speaks louder than any slide. You guys are aware. Was formerly called Office 365, launched more than 10 years ago, just insanely popular suite of productivity tools. It's mainly cloud-based Microsoft Office, but there are also a lot of other services there. Microsoft Teams is very popular. Exchange Online, Skype, SharePoint, OneDrive. You can see the lineup. Oops, sorry. Wrong button. OK, so you can see a lot of services there on the slide. More than 300 million active monthly users. More than 2 million organizations are using it. A lot of small businesses are using it. Actually, it looks like the majority of customers are small businesses. And they just dominate the Office market suite, or the Office suite market. When we talk about Microsoft 365, we also have to talk about Azure AD, or Azure Active Directory. And what that is, it's a cloud-based directory and identity management service. It actually differs from Active Directory that you may be familiar with in your local networks. It's a similar name, but there are a lot of very different concepts there. So it's practically a different service. And in our context, it's important to talk about it because that service provides authentication and authorization services to Microsoft 365 users. So you can imagine that essentially gives you keys to using Microsoft 365. If that gets abused, the attacker is into the environment. There's nothing else that's there to stop them. It's pretty powerful. It allows you to sign up for services, access them with a single set of credentials, provides access to both cloud and on-prem applications. And there are a lot of features there. There's modern authentication, syncing with local Active Directory, federation, device management, you name it. And as you can see from that picture there, you can use it to protect cloud services. You can integrate with external identities. You can protect your own business applications that you developed in-house. You can sync with on-premises Active Directory. So it does a lot of those things. And almost 500 million daily active users. So these are very, very popular applications and services. So just to give you a picture of how it all kind of fits together, Azure is this ecosystem that Microsoft has. There are different silos there. You can use it in different ways. You can use it as infrastructure as a service, as platform as a service, software as a service. So Azure AD is an example of platform as a service, where it provides identity services. And Microsoft 365 is one of the software as a service types of software. So why does it matter, really? Like, what are you going to steal when you abuse Microsoft 365? Isn't it just PowerPoint presentations, Excel spreadsheets? Actually, it's more than that. If you have gone through migration to Microsoft 365, you know that it sort of like becomes the lifeblood of your business. There are a lot of corporate documents and data that are stored on SharePoint drives, on OneDrive. And sometimes that includes all kinds of juicy IT information, passwords. A corporate email has all kinds of private information that businesses don't want revealed to the world. Finances, accounts, credentials. Teams has recently become one of the busiest, most used services in Microsoft 365, and there's a lot of information shared through those chats, some of it very private. So it gives you a lot of opportunities for stealing sensitive data and exfiltrating it, and there are added extortion opportunities there. I'll talk about that a little bit further. User impersonation, when you take over the user's account, will lead to lateral movement, and you can spearfish and whale within your organization to attack the colleagues of your victim. You could actually use this environment to set up a command and control network to attack further. And another thing that's sometimes overlooked is that you could pivot into other services, because in businesses you're often integrated with things like HR systems and marketing systems, and there's one identity that ties that all together. If you compromise it, you could go laterally into those systems and abuse them as well. You could pivot into other cloud systems, and you can even move into on-prem environments, so attack top-down from cloud into your local network. So cloud does come with promise of better security, and I would say for the most part, it actually holds true. Many attack scenarios that are plaguing local networks are essentially eliminated when you work with the cloud. But there are other scenarios, other weaknesses introduced. Proxy shell is a good recent example of that. It's a family of vulnerabilities in Microsoft Exchange, in the on-prem versions that you would host yourself. And there are, even though the vulnerabilities were announced, like a year ago, and they were actually very widely exploited since then by all kinds of attack groups, there are still instances out there that are vulnerable. And I would predict that several years from now, we would still be suffering from that. However, Microsoft has Exchange Online, which I suspect shares at least some code base with Exchange. They haven't said that it's vulnerable, but if it was, they would likely patch it even before these bugs were announced. So that kind of gives you a very good example of the power of that service that cloud providers give you. They could really do patching across the board and do away with a lot of 0 days. However, cloud providers are not magical. They do not secure everything. And there's something that's called shared responsibility model. So essentially what it is depending on the type of service that you've purchased, provider and you as a customer, you have different responsibilities. So like the rightmost column there, the on-prem, means that was essentially the old style where you have your local network. You're responsible for everything. You're supposed to secure everything. But as you move left, from model to model, with software as a service, which Microsoft 365 is, customer actually is responsible for just the contents of those services, for properly configuring them. And Microsoft takes care of the underlying infrastructure and the security of the software. So that's where the division lies. So as I said, infrastructure is secured and patched across the board. 0 days have very limited shelf life, but as you'll see further, a lot of attacks end up being against the configuration or the part that the customers are responsible for. There are a lot of other positives for doing it this way. So there are uniform APIs across all the customer base, rather than having each customer have their own set of software that they have to maintain and protect. They're unified APIs that are better understood, better protected. Specialization also promotes security. Cloud providers have very good visibility into all their customer environments, so they could not only fix individual customers' problems, but also can spot security problems across all their customer base and react. They could actually look for patterns of abuse. This functionality is relatively new, so attackers are still getting up to speed. That's sort of like an unintended positive here. So there's not as much expertise there for attacking the cloud. And the last point is debatable, but in this case, it does help that cloud functionality is essentially a black box. Like I mentioned that I love reverse engineering. For me, to look for vulnerabilities, I would pull down a piece of software and actually pull it open and look inside and try to see where the vulnerabilities lie. For the cloud scenario, that's very difficult to get your hands on that software and really understand where the holes are. So that, again, contributes to security. Although security by obscurity is not a good idea. Just want to make that clear. The fact that it's relatively new actually also plays against security because there are not as many defenders. Like we had a presentation this morning, the same point was raised. There are not enough cloud security talent out there to help protect things. Attack surface is wide open and shallow. So before you would need to compromise the outer perimeter, then move laterally, try to escalate. Now there's no perimeter. You compromise the identity and you're in. You could start abusing your victims. So all of these things are kind of not so good things. So configuration mechanisms are at times hard to understand, hard to use properly. Admin tools and security and monitoring tools, not perfect. There are some blind spots. Visibility is limited only to what you can see in the logs. So before, you had full control of your network. You could put all kinds of listening devices there. You had a choice of software. Here, essentially, you have a choice of what vendor gives you in terms of security tools, and you have logs. And that's the only thing you can deal with. And there are their own issues there that I'll talk about later. And sometimes security features that you have available to you depend on subscription levels, and those can get pretty expensive. I can see in our customers, they're sometimes hesitant to get extra security protection that they need because it costs a lot. So attack trends have been steadily increasing in recent years, not necessarily because Microsoft 365 is easy to exploit, but just attackers move where customers are, where the data is. And COVID, of course, put everything into overdrive. Everyone started to migrate online. People just, were on a schedule to really quickly migrate everything to the cloud so that their employees could still operate. As a result, attacks also grew at a higher pace. And this is a kind of a shocking number that some of my colleagues gave me, the ones that deal with security posture in Microsoft 365. Past 2 years, over 300,000 attacks of different sizes. So that's a lot. There were recent high-profile attacks in this area. The most famous one probably was against SolarWinds. We know it as mostly on-prem attack, but it included a cloud portion. There were certain techniques that attackers used. They used golden SAML that I'll mention later on. They modified trusted domains, abused basically domain federation that's possible. They maintained access to victims' mailboxes to siphon off emails. They hijacked Azure applications to give them additional power. So they understood the power of Microsoft 365 and used it against the victims. Lapsus had some of the techniques in this environment. They abused admin accounts to essentially lock the customer out of their system and siphoned mail out of the environment. There was this group called Kryptonite, Panda. They had different set of operations. They would basically phish their users. And then once they get in, they would steal data from OnDrive and also use that infrastructure as a command and control setup. So as you can see, different attack groups, different techniques. And of course, there are many, many more cases out there. I pretty frequently read in the news about what attackers are using. So for us to kind of enumerate what different techniques there are, MITRE ATT&CK, you probably have heard about it. It actually has a cloud portion to it, and specifically for Office 365 and Azure AD. So if you're defending that environment, it's good to check out. There's a nomenclature of different methods there, and it's growing. People are improving it all the time. So check it out. So let's go through some common attack techniques against that environment. Of course, password attacks are very popular. There are all kinds of types of brute forcing that we're seeing. But Microsoft, of course, is aware that people will try to get into these accounts. They have measures in place to detect some obvious brute forcing attempts. So like things like auto account lockout would kick in if they notice some malicious behavior. So attackers have to adjust to that as well. It's a constant arms race. So in the tools that attack tools that I'm seeing, there are ways to introduce delays to space attacks out in time. There's jitter to make sure that attacks don't look like they come from an automated tool. They look quasi-random. Attackers often use VPNs, Tor proxies, in order to either imitate logins coming like from all over the world, or if they're going against someone specifically, like let's say they know that their victim is based in Quebec, they'll try to find a proxy that has an exit node in Quebec and use that for password attacks. Password spraying is also very popular because it helps bypass that Microsoft detection and auto lockout, because if you don't know what it is, basically you have a set of passwords that you want to try, you have a set of victims, and you would take the first victim, try password number 1 against that, then same password against the second victim. So you go breadth first. And then once you've gone through the list, you try the second password against all of the users. And what this does is you spend the same total amount of time to try to find your way in. But to Microsoft, it looks like the attacks are really spaced out. And it doesn't look as suspicious, like someone is pounding on the door. When we talk about password attacks, what's the first thing that's recommended? Multi-factor authentication, of course. It's a great way to protect yourself, but it's not perfect either. And actually, there are two popular tactics that are making the rounds now. Attacker in the middle and MFA fatigue. Attacker in the middle is where they are phishing the user with a fake login prompt. And the website is made to look exactly like Microsoft sign-in prompt. So a user that's not very attentive, they would actually try to log in. And that also includes a field for the MFA code. So the user does enter their MFA code, but that gets sent to the attacker, and they use it to steal the user's session. MFA fatigue, this is how Uber was popped recently. They would just bombard a user that has a push-based MFA set up on their account with these hundreds of prompts, like at 1 o'clock in the morning, and in the hopes that user in the end will just give up and say, OK, and attackers are in. And there are other ways to bypass MFA they're used. They try to social engineer SMS codes. They steal cookies when they can drop malware on the user workstation. There are legacy APIs out there that Microsoft still supports, and they recommend that you disable them, but not everyone does. You could try to brute force IMAP, POP3 more easily than modern authentication. And once they get in, they can try to disable MFA for selected scenarios, and also change trusted network settings so that they're no longer prompted for MFA. Phishing, of course, it's been in the news forever. It's also used here very frequently. They're sending malicious attachments, links to websites that drop malware. But the added twist is that, as I mentioned, they send links to these fake login portals that look like Microsoft sign-in prompts. And there are all kinds of phishing there. Usually kind of regular phishing coming from outside, and once you're in, you could try spear phishing or whaling to try to compromise a specific set of users that are really high value. There are other ways to get into the environment other than by entering your password. There are federated relationships that could be set up so that, let's say you're authenticated by Google, you'll also be authenticated by Microsoft. And that gets abused. And also attackers, when they get administrative powers, they set up their own federated relationships to get into the environment easily. Golden SAML technique that I mentioned in the past, this is sort of on-prem to cloud type of attack where they take over the on-prem Active Directory and are able to mint their own tokens to get trusted access to the cloud account that has this trust relationship. And of course, if you get malware on your machine, they can just steal your browser cookies and use that to take over your session. So you don't need to give up your password to get exploited. Once attackers get in, they try to get persistent access so that they could keep getting in even after they are kicked out. So there are a number of techniques that we're seeing. So there's a creation of new accounts with elevated privileges. New powers to existing accounts are given sometimes. There are redundant keys, additional MFA factors that are given to user accounts. There is abuse of services principal. Service principal is this system type account that often gets overlooked, but it can act just like a user and do pretty much everything the user does. And that's actually what the other technique does, where users are tricked into giving malicious apps permissions to act on their behalf. You may have seen these this permission consent grant prompts sometimes where when you try to use a new app, it would say this app wants to access to your email or to your profile picture or something like that. So they would use malicious apps to get permission to act on users' behalf and then do whatever, read email, do all kinds of things. Recon is a difficult topic in Microsoft 365. When the types of recon I've seen coming from outside, from unauthenticated user, has been primarily about them trying to detect what kind of different valid usernames there are. So they would try different name and last name combinations in the hopes of hitting an account that actually exists. And once you're in, Microsoft APIs allow you to pretty much look at anything. If you have the right permissions, you could enumerate all the services, all the resources in the environment. The big problem with that is that none of the recon activity is logged in the logs. So as a defender, you're just blind. You don't know who is looking at what. It probably was a conscious choice by Microsoft, and I've seen this with other cloud providers as well. Maybe this is because of the volumes that you will get. Logs will just explode if you log those kinds of requests. But the end result is, as a defender, you're blind. You don't know if someone is looking around. Attackers, if they get that power, they would disable different security mechanisms or maybe adjust them so slightly so that they would be invisible. And disabling logging is probably, like if I were an attacker, I would probably go for disabling logging altogether. And then, because that's the only thing that defenders really have, then nobody can see anything and I can just keep going. And there are other security mechanisms that could be disabled. Malicious email rules, they kind of stand by themselves because of how often I see them. When I get to look at kind of post-mortem of an incident, almost every time I see a malicious email rule created. So what attackers do is they get into the account, they send emails on behalf of the user pretending to be them, and they create email rules to hide the responses, to delete the responses, or sometimes just to siphon all the incoming email from that user's colleagues to some external system. And this is actually an example of a rule that I've seen in the wild. You notice that the name there is just a dot, so they made it so that it would look very, the visibility would be as little as possible on the list of email rules. There are all kinds of interesting keywords in the rule, and in this case, they are deleting this message. So essentially, they're trying to hide from the user the fact that their account was taken over, and when that user's colleagues are getting suspicious and they're writing to them, hey, was your account hacked? Those kinds of emails will not be shown to the victim. Power Automate is a very interesting feature in that environment. It's essentially a low-code programming environment where you have these building blocks called connectors. And there are connectors for flow control, like if statements, loop statements, and services. And there's a catalog of connectors for like hundreds and hundreds of different types of connectors for interacting with all Microsoft services, GitHub, Twitter, Facebook. So you could build these little, really powerful programs that would, let's say, collect incoming email and send it to someone else, or collect all new files from a SharePoint share and upload to some external site. You could really exploit this functionality for malicious purposes. We're not seeing this yet. It's very rare that we're actually seeing this in action, but I think it's coming. I think attackers are learning how to do that, and they will actually start abusing it. And you could build all kinds of things. Even you could build a working command and control framework just using this functionality. E-discovery, another very, I would say, dangerous tool in Microsoft 365. This is a tool for lawyers when they have to do legal discovery and they have to collect all kinds of facts about, I don't know, some legal incident in the company. This tool gives the user, lawyer, I guess, power to look in everyone's email, everyone's files. Basically, they can see everything in the environment. So as you can imagine, if an attacker can exploit the user that has that power, they could pretty much look everywhere, see everything, collect and exfiltrate data. So it's really important to watch for how this, who you give access rights and how it's been used. So once you've stolen a bunch of stuff, you want to exfiltrate it, and OneDrive and SharePoint sort of lend themselves to that abuse. Like they're just, in some way, they're like S3 buckets. You can give anonymous access to certain shares. You can collect data there for exfiltration. And sometimes we see that once attackers get into the environment, they host malware there. So they would, let's say, create a Excel spreadsheet with macros. They put it on a SharePoint share and send the link to that to all the colleagues of the victim, hoping that somebody will get popped by that. There are also ways to siphon things from Exchange mailboxes by giving an external user read access to the mailbox. Microsoft Teams has guest access, so if somebody gets that, they could read all the conversations. So it's really a lot of functionality that could be exploited. Finally, ransomware. Ransomware has been in the news a lot lately. It's probably one of the favorite things for attackers to do that nowadays because it pays really well. But interestingly, in Microsoft 365, we haven't really seen any incidents or any serious incidents that would be announced in the press. And I think that's because of some mechanisms that Microsoft put in place. SharePoint and OneDrive data, they have built-in versioning mechanisms. So when you make a change, it creates a new version of the file and keeps the old one. There's a limit to that, and actually some researchers suggested that you could either reduce the max version number or exhaust it, but it gives this rollback functionality to almost every file you create there. So if you encrypt it, there is a way to get that data back. And I think Microsoft also has some internal backing up of data going on. So it's not as easy for attackers to abuse that. In the past, attackers have been, like I think Lapsus does that, have been trying to lock the customer out of the environment by creating their own admin account and deleting others. But I think Microsoft has the power to override that, so there's a solution to that. Mitnick created a proof of concept for encrypting Exchange mail and keeping it for ransom, but that was a theoretical exercise. I've never seen anyone use that technique. There is a functionality that theoretically could be used for ransomware. There's something called customer key or bring your own key, where if you don't trust Microsoft with looking at your data, you could hold the encryption key, and Microsoft will just see a bunch of gibberish. But that puts responsibility for safekeeping that key on you. So if you're not careful, somebody takes over the admin account, they could rotate the keys so that the keys are new, they're not backed up anywhere, and only the attacker knows them. And now they own access to your data, and you have to pay ransom. And Microsoft cannot help you, because by design, you are the owner of the key. So again, this is a theoretical thing. I've never seen it done live, but it's a possibility. But overall, I would say it's a safer environment for ransomware, in my experience. So we've seen the attacks. What are the tools? So Microsoft has done a pretty good job of creating all kinds of security tools. There are all kinds of facilities in the identity service to have groups, roles, security settings. Like it's a full, very powerful set. Microsoft Defender is, I would say, is a primary solution for security. There are all kinds of spam and phishing and safe attachment protection. So it's just a matter of making sure that all of that is enabled. And Microsoft Sentinel is their CM solution. This is, by the way, part of Azure. It ingests logs from different sources. There are lots of built-in detections for malicious activity. So you could use that if you want. Azure Log Analytics is a great log analysis platform. They have a special query language for logs called Custo. I don't know why they didn't go with SQL, but I guess it was their choice. One more thing for users to learn. But it's really, really powerful. I was actually really impressed about how quickly you can query the logs. They must have massively indexed data on the back end or something. Queries over big logs return really quickly. So it's really a pleasure to work with when you're investigating an incident. And there are, of course, always all kinds of third-party tools that add value that you could purchase. Logs, as I said, it's like your only window into what's going on in that environment. There are two different sets of APIs for accessing the logs. There's a new style called Graph API, and they have different flavors of logs for different types of identities: interactive, sign-ins, non-interactive, and so on and so forth. And there's a log for what's going in the directory, the different actions that are happening there. And there's an old-style API called O365 Management API that has events for things like SharePoint, Exchange. And some of the events are duplicated between these two sets of APIs, but it's not a big deal, as long as you have the coverage. And if you look at the logs, you will see the type of information you would expect the log to have. There's a timestamp, there's information about who the actor is, there's like IP, username, Sometimes there's geolocation, device information. There's a target, what the operation was done against, operation name and details, result status. So there's a sizable amount of information. However, logs are sometimes very difficult to deal with. Schema is not fully documented. Sometimes there will be a case that there's authentication code 537, and you look online and there's nothing. There's zero documentation of what that means. And I've seen these cases a lot. So documentation is not complete in terms of what gets into the logs. Schema is fluid. So you get new types of operations logged. The way Microsoft decided to address that, let's add another column to your log table. So sometimes I see errors, Microsoft errors, saying that the log table size is more than 500 columns. I mean, it's just, there's a limit. I mean, they could have, I think they could have handled it better. Information between different logs is not consistent. Sometimes you have just the IP and username, and sometimes you have geolocation, other stuff. So it would have been great if they made it more uniform. And with individual log records, there are also sometimes there are problems. Some things do not get logged at all, so there's a blind spot. Things may arrive out of order, be delayed, be lost, and logs also expire. So I think after 3 months, you lose the data that was there. So if you're trying to do historical review of what that user did, you only have a window of 3 months. If you really want to look into the past, you have to actually offload that data and keep it somewhere else. I think the basic problem here is that even though Microsoft does have service level agreements for these APIs, requests have to execute in a certain time frame, and they support this many requests per minute, so on and so forth. They don't have a contract with us as customers as to the log content. They can change things like the data types, the formats in individual log records, and not even announce it. And for us as defenders, it's really hard. So be ready for that if you're dealing with log analysis. Just as their defender tools, their attack tools as well, security community has been really active in that area. I count more than 30 tools in this space that do all kinds of things, but primarily concentrate on either password brute forcing or recon. So you could use that as part of your red team exercises to actually go against your environment and see if you could exploit your environment. There are 3 interesting examples. AD internal, which is like a really rich set of attack functionality. Azure Hound is a plugin into Bloodhound, if you know what that is. It's a tool for exploring your on-prem Active Directory. Azure Hound does the same thing, but for Azure AD. Vajra is a small tool that somebody built. I found it interesting because they went beyond just password attacks. They actually tried to implement a consent grant attack, data exfil. So there's some interesting information there. So we have, we know what the environment is. We have information about attacks. We have the tools. How would you approach actually defending this environment? Defending Microsoft 365 is different from your on-prem, and I would say 3 main areas are education, configuration, and security monitoring. Humans are and have been like the weak link in security equation. I would say it's partially fault of us as security industry. In other areas of technology, people were able to come up with solutions that protect the user against stupid things that the user could do. But with passwords and some other mechanisms, we're still not there yet. It's very easy for someone to create an insecure password, reuse it, and have their account exploited as a result. So we still have ways to go. But even though it's not something we can solve right now, and I don't know how soon we can solve it, it doesn't mean we should stop trying. I think educating users is very important. If you try to solve it only through technology, it's difficult. If you set permissions really strictly, users will refuse to use your system. If you relax them, users will go with the flow and take the easiest way. So I think it's very important to keep educating your employees while keeping in mind that everyone is human, the people will still make mistakes. It's a very good book that I read recently. If you're looking to set up that employee education program in your enterprise, I would recommend that you read that because it has a lot of very interesting information on how to do that. And it's not saying that, yeah, we'll solve all your problems. It's actually a very level-headed approach to describing how to do it and what to expect from such a program. As far as configuration is concerned, most of these recommendations will make sense to you. Like, there is no rocket science here. Even though MFA can be bypassed, it's a very good idea to enforce that. Disabling legacy authentication, encouraging strong passwords through various means. There could be password managers, complexity requirements, checking for common weak passwords. There's new technology called FIDO2 that does away with passwords. And I would, if you are in position to actually implement it, because not everyone is, technology is still not there across the board. But if you are, I think it's a way out of a lot of these problems. And of course, hardening the security of admin accounts. And there are all kinds of other recommendations you can read about online. Like you make sure you enable all your security mechanisms, including logs, audit user access rights. Because where you want to be is that the user that maybe is gullible and can be exploited with phishing, they should have small enough set of access rights so that even if their account is exploited, they cannot do much damage. And the really serious admin accounts, those people should be really educated on what to do and not to do and have all kinds of protections around the access. And there are other things. So there's conditional access, restricting guest access, restricting consent to kind of random apps. Microsoft 365 Defender has a big dashboard with all kinds of recommendations that you could follow. But with configuration, there are two additional problems. Number one, you cannot secure things and call it a day. It has to be a continuous thing because the environment itself is fluid. You're adding users, you're deleting users, you're creating new shares. Like, things are moving around all the time. So if you're secure today, you may be insecure tomorrow. So you need something that continuously checks your posture. Also, this number is again coming from my colleagues in posture management. There are over 7,500 different security settings for individual user. Like, I was blown away when I heard that. And that's not to mean that in the user UI there are 7,500 different radio buttons and checkboxes. There are a lot of subtle security settings that you can only access with PowerShell. So there are like pages and pages of different PowerShell commands with all kinds of little features here and there that somebody could execute to open up a hole. So I think it's obvious you need some kind of solution to this. I would recommend having a security posture management solution that you implement that checks your security, that prioritizes the changes that you need to make to be secure, and that does it continuously because things change all the time. Finally, security monitoring. There's this famous quote that there are companies that have been compromised and the ones that have been but just don't know it. It rings true. Even with people properly trained, things configured properly, we all know things will just happen. You need to continuously monitor what's going on in your environment. And if you are a part of a big company that has its own big security team, and maybe even a security research department, you could sort of build your own solutions there. You could build threat hunting queries. But most customers are not like that. So they opt to either stay in Microsoft Sentinel and use Microsoft-provided detections, or they can flog logs into an external logging solution. Unfortunately, not all tools are created equal. The biggest problem, I would say, is the alarm volume. A lot of vendors, what they do is they create a detection that's very simple by nature. Oh, this thing happened, send an alarm. But we know from experience that users do a lot of really strange things as part of their daily work. So if you have a detection that says user logged in from Canada, but they've never been to Canada before, that's an alarm. Alarm volumes just explode. And just to give you a recent example from a customer situation that we had a user from a European customer travel to US, and they've never been to US. And the company, I don't think, even does business with US. So a simplistic detection system would say, well, that's a detection, that's an alarm. But it was a valid trip for them. But while they were there, their session was actually stolen by someone. And that person logged in from other parts of US with the same account. That's a malicious way of using the same account. So simplistically implemented detection system would not catch that, and it would probably opt to just bombarding you with thousands of detections. So what I would recommend is to, if you're considering a detection vendor, look for someone that can raise alarms based on context, on environment trends, history, location, threat intelligence. And this is something that vendors that use artificial intelligence, machine learning, I think they have a leg up on others in spotting those trends. So to wrap up, Microsoft 365 is this big, juicy target out there, and vast majority of attacks against it are sort of centered around misconfigurations, social engineering, and thankfully Microsoft takes care of security of the infrastructure. 0 days do appear, but they're far and few between, at least the ones that are announced, and they're fixed quickly, to Microsoft's credit. So if you want to secure your environment, you need to educate your users, but not depend on that, because people will fail invariably. Harden your posture, and ideally have some kind of automated solution to check that hardened posture continuously. And finally, monitor your environment for malicious behavior, but do that, again, with a solution that does it intelligently. Otherwise, your analysts that respond to alarms will be overwhelmed. And that's it. If there are any questions, I'll be happy to answer, or I can hang around outside the door afterwards. And with this, I thank you. And there's slides also, like if you want to download slides, there's a QR code for that. Thank you.